Welcome to this explainer. Today, we're skipping the theory and jumping straight into a mission briefing. We're looking at a complete guide to building your very own off-grid tactical mesh network using OpenMANET and Wi-Fi HaLow. So if you've ever needed high bandwidth, long-range comms that are completely, totally disconnected from the internet and commercial cell towers, well, you're in exactly the right place. Let's face the fundamental operational problem here. What actually happens to your tactical comms when the grid goes down? Think about it. Whether you're operating in a disaster response scenario, out on a search and rescue mission deep in the backcountry, or running an off-grid civilian tactical event, centralized communications are usually the absolute first thing to fail. And historically, our fallback options have been pretty incredibly limited, right? We're talking low bandwidth text messaging or basic line of sight voice radios. But what if you need to stream video, share live map overlays, or have encrypted multi-party voice chats without a single cell tower in sight?
Okay, let's dive into this. Here's our briefing itinerary for today. We're going to cover the off-grid comms challenge, the Wi-Fi HaLow solution, building your tactical node, deploying ATAK and Jami, and finally, a HaLow versus Meshtastic comparison.
Section 1, the off-grid comms challenge. Let's get right into establishing our operational environment. So, to solve this off-grid problem, we really need to understand what a MANET is. It stands for Mobile Ad Hoc Network. Basically, it's a self-forming wireless mesh where every single node connects directly to the others, completely bypassing any centralized infrastructure. There's no master router here. There's zero central server. If one node goes down, the network just instantly self-heals and routes traffic right around the failure. Honestly, it's the ultimate resilient network for search and rescue, disaster response, and totally disconnected communications.
Moving to Section 2, the Wi-Fi HaLow solution. Let's look at the specific radio tech that makes this high-bandwidth, off-grid mesh a reality. The architecture here relies on a really brilliant two-part system. You've got the local handset link and the long-range backhaul. Here's how it plays out in the real world. Your standard Android phone connects to your local tactical node, a little box in your backpack, using standard everyday 2.4 gigahertz Wi-Fi. But then that node uses a Wi-Fi HaLow radio broadcasting on sub-1 gigahertz frequencies, usually around 900 megahertz, to create a long-range backhaul to other nodes. This sub-1 gigahertz frequency, that is the magic key. It gives you incredible kilometers-long line-of-sight range, and it easily punches through thick foliage and concrete walls, stuff that would instantly block normal Wi-Fi.
To really wrap your head around how this functions, I absolutely love this quote. Imagine the mesh network as a giant, transparent, invisible Ethernet switch stretching across kilometers of terrain. This whole thing is possible thanks to the BATMAN advanced routing protocol used by OpenMANET. Now, BATMAN operates at layer 2 of the network stack. In plain English, that means it acts exactly like a physical network switch. If a node needs to talk to someone hidden behind a hill, a relay node up on top of that hill simply passes the Ethernet packets back and forth transparently. As far as your phone is concerned, every device feels like it's plugged into the exact same physical switch right in the same room. Now, a super interesting data point you gotta see is this number, 27 dBm. You see, the OpenMANET project isn't just running standard off-the-shelf software. They're actually using a custom board data file, or BCF, specifically for the Morse micro radio chips. This custom config literally cranks the transmit power up from the default 21 dBm all the way to 27 dBm. Now, in the RF world, that is a massive, massive increase in power. It vastly improves your node's ability to punch through environments and extends your range way beyond standard factory setups. All right, Section 3, building your tactical node. Time to shift gears and actually build our hardware arsenal. Okay, here is the exact hardware arsenal you need for a single tactical node. You start with a single board computer, typically a Raspberry Pi 4. Slap a Morse micro-based Wi-Fi HaLow hat on top of that. Seed Studio makes good ones. Then you're going to need a high-quality 900 megahertz SMA antenna, a solid 5-volt 3-amp power supply, and of course, a weatherproof IP67 enclosure if you're taking this outside. But listen to me very closely on this critical rule. Never, absolutely never power on your Raspberry Pi and HaLow board without that antenna securely connected first. If you do, you can instantly burn out the RF power amplifier and completely ruin your hardware. Deploying the node is a pretty structured 3-step process. Step 1, assemble your hardware and attach that antenna. Step 2, download and flash the OpenMANET firmware image onto a fast micro SD card, then boot up your Pi. Step 3, configure the network. The Pi is going to broadcast a standard Wi-Fi network for your phone to join while simultaneously bringing up the HaLow link in ad hoc mode. Honestly, all you have to do is assign a unique static IP address to each node, and boom, your mesh is alive. So, a really crucial point here is understanding this specific subnet, 10.41.0.0/16. The OpenMANET mesh exposes this flat local area network to all the end users. Every single mesh point keeps its own DHCP scope. What that means for us is pretty simple. If you connect your phone to a node's Wi-Fi and your device gets an IP address starting with 10.41, you are golden. You have successfully joined the tactical mesh. You are online and instantly ready to communicate with anyone else sitting on that 10.41 network. Now, I want to give you a highly valuable, field-tested technical tip. If you're deploying a node strictly as a relay, let's say you're leaving it in a weatherproof box on top of a hill with a solar panel just to bridge two valleys, log into the OpenWRT web UI and completely disable the 2.4 GHz Wi-Fi access point on that specific device. Since no one is going to be physically standing next to that Hilltop relay trying to connect their phone, turning off the standard Wi-Fi drastically reduces power consumption. Plus, it cuts down on the heat generated inside your enclosure, which really maximizes your battery endurance. Moving right along to Section 4, deploying ATAK and Jami. Hardware is done, so let's look at the software payload. Let's see exactly how this builds a massive operational advantage using ATAK, the Android Tactical Assault Kit. Because OpenMANET emulates that virtual Ethernet switch at Layer 2 we talked about, ATAK works absolutely flawlessly using its native UDP multicast settings. You do not need any complex forwarder plugins to make this happen. You literally just turn it on. Real-time cursor on target location markers, tactical map overlays, drawing tools, and even push-to-talk voice communication through the VX plugin. They all just flow seamlessly right across the HaLow mesh, updating everyone's situational awareness instantly. And for your secure peer-to-peer comms, this system integrates beautifully with an open-source app called Jami. Getting Jami to work entirely off-grid without any internet name servers is super easy. You just need a few specific settings. First up, enable local peer discovery. Second, disable the DHT proxy setting so the app stops trying to ping the cloud. Finally, just exchange your 40-character raw Jami IDs with your teammates. Once you're connected over that 10.41 mesh, you're getting high-quality, full-duplex encrypted voice calls, video streaming, and secure file transfers. No internet required. Finally, Section 5, HaLow versus Meshtastic. Let's do a quick tactical comparison. And this really brilliantly illustrates the difference in capabilities between these two systems. We're looking at Meshtastic running on LoRa versus OpenMANET running on Wi-Fi HaLow. Now, Meshtastic is fantastic, don't get me wrong, but it is strictly ultra-low bandwidth. We're talking maybe 1 to 5 kilobits per second. It's designed primarily for minimalist text tracking and short GPS bursts. It absolutely cannot support voice. OpenMANET, on the other hand, that gives you 150 kilobits to over 15 megabits per second. You're getting full IP networking, Layer 2 mesh routing, full native ATAK capability, plus continuous encrypted voice and video. It really is a true tactical IP communications platform. Okay, before you head out and deploy, you need to burn these best practices into your mind. First, keep your antenna cables as short as humanly possible. 900 megahertz RF signals degrade incredibly fast over long or cheap coax cables, so ideally mount your antenna directly to the SMA port. Second, verify your regional RF compliance. Make sure your transmit power and channel frequencies actually match your local ISM regulations. And lastly, for field power, invest in power banks that support pass-through charging or build some custom LiFePO4 battery boxes so your nodes stay alive through extended operations. We have covered the hardware, the software, and the undeniable tactical advantage of owning your very own high-bandwidth, self-healing infrastructure. So I'm going to leave you with this thought. How will high-speed, off-grid IP communications change your team's next deployment? Remember, the grid doesn't have to be up for your team to stay connected. Grab your hardware, flash your nodes, and go start building your own invisible Ethernet switch. Thanks for joining me for this explainer, and I'll catch you on the next one.